Hi there, welcome to lesson 9. Thank you so much for paying attention and getting to this level. I hope it has been worth your while. So this particular lesson, we're just going to do a practical session that integrates all that we learned from the very first lesson up till now. So please pay attention to how I tweak things. I introduce a little more options, and then flexibility in style. Actually, when I use the use command, I do not use cd, and the idea is to show you that without cd you can still achieve your goals of saving files, importing files, and using files. So just pay attention and then tweak. I don't mind if you do your own rehearsals or task and you decide to use cd, but the whole idea is to see the options down the table and how useful they may be when you need to use them. So without wasting much time, I'll see you in the class shortly. Bye for now. So hi there, welcome to module 3, the final lesson for the practicals. So we're looking at virtually everything that we have learned in this session, and we're going to be using this data set that is already by default on your laptop. So if you have Stata installed on your laptop, this will work. I had already told you that when you use sysuse, what it does, it brings out the data from the pre-installed Stata. So if you have Stata installed, this would work fine. So the first thing is to generate. So I would clear whatever data was there, so no more data is there. So that's all I did. And to just check, we go to our data editor, it's all empty. So data editor is empty, and then go back to do file. So we can load the data set now by just selecting those two lines. So this is a data set that is used, I think it's a national longitudinal survey for women. Now nobody knows what NSLW is, so it will be better to give it a better name. So I will just give it the name, label the data with something that is a bit more descriptive. NLSW really doesn't mean much. So label data, and then it's a string, and then we have National Longitudinal Survey of Young Women. Please always ensure that it's not more than 80 characters. So you could do the counting yourself, but I'm very sure this is no longer more than 80 characters. So that's the first thing I want to do, label the data. So I hope that makes sense. So the other thing I want to do now is I want to save the data, but let's just have a quick look. Let's go to the data editor and have a quick look. So it's basically about women. We've already known that. So the gender is all women. Here, their ages, their race, their marital status, college degree, and some other data that may be useful. So that's how it looks like when you just use the basic use command. So I'm going to save it now, and I want to save it somewhere in my own folder on my own system. So to save it on my system, I need to go to my Windows Explorer and trace down my Stata Sage folder, and this I will just write here folder and probably call it a module 2 folder. That's fine, and then press enter. The whole idea, there are other ways of doing this. I could also decide that I wanted to copy the path by right clicking, or on Windows Ctrl+Shift+C. So I've copied the path. This is where I want to save the file I just opened. I will now come back to my do file editor. Just a minute. Yeah. And now I'm not going to use the cd command because I've used it quite for some time. I'm going to change it now. I'm going to say save, and then the file path. The file path there is just has only one inverted commas. This is the file path where I'm going to save the file, and I don't want to change it. I don't want to change anything, including the name. So nslw.dta, comma, replace. Now replace is very important, especially if the file had never been created. If the file had been created before, then it overwrites it. But if you don't want to overwrite it, then it will show an error by the second time you are trying to run this do file. So let's take it nice and slow again. Just let me go through everything. First, we clear. I'm sure you know why we do that. Then in line 4, we are using sysuse. In line 6, we are labeling data with a more meaningful name. And that's why we have it all written that way. I had gone to copy the path where I want to save the folder. So I told you. Another way of doing it is actually typing cd and say this is the folder to concentrate on, or you just type where you want it to be and add the name you want to call it. So I don't want to change the name for any reason. I will now run this. So I'm going to run these 4 lines of code. I save and I run. Now when you look at your main windows, it will tell you that this file was not found and therefore it has been saved. Now if I try to run it again without the replace, just to let you know, and just before I do that, let's go back to the folder where we had module 2 and check. So if we check now, we see that the file is saved there. So if I try to run this do file again, I would have an error. So it says this file already exists, so you can't overwrite it. But by adding comma replace, which is like default best practice, what it does, it overwrites what was there before. So you could check the time. It was 9:33. You come back, just give it some few minutes and go back again. Then you see that it keeps replacing what was there before. Now that I have done that, I also now want to use the use command. Now this is the file I want to refer to. I'm no longer altering or working on the file that comes with the default data. So we are going to use the use command. We would use the use command. So we just type use, but now I want to add an option. Remember, we had done this in module 2, so I'm sure you've matured with this, an option to the use. So the main command, then you do whether you want it with jam, you want it with butter or margarine, or you want it with scotch egg. So I'm going to use in a very special way. So I'm going to still cut this address. So for the first time, I'm not using cd command. I just want to use the direct file path. This is where I saved it, and now I want to call that file I saved. Now I've told you, because there's a file on the system already, it's best to add comma clear. Now you see this is save file path or file name comma replace, and then we have use comma clear. So oftentimes in your career you're going to use this, and this is one of the best practices and fastest way to get up and running, either when you want to save or when you want to open a file. So I'm going to add another option. There was clear as an option, and now I'm going to say no label. Now if you remember, we had several blues when we were using sysuse, and I'm happy to go back to check and show you. Now all I'm doing is I'm stripping the file I saved as label. Not only that, I also want you to test whether this label you had written here, National Longitudinal Survey of Young Women, has now registered in this saved file. Remember when we talked about saving, some things have happened. When you were running, if you look, it was just showing a very short label, but right now we have a longer label. Let's see what happens when we open this file. Now no label means I strip all categorical variables of their labels, meaning I turn all blues to black. That's basically what it does, and I will just let you know why. And the whole idea is just because I want to define labels and I want to add them. So let's now run everything again. So now when you run, can you see once the file loads, it takes this new label you give, which has more details. Now you may also want to add the year that this was done in 1988, I guess. You know, can say 1988 extract, which makes right. But please note, it should not be longer than 80 characters. So let's run again from beginning to end. So it takes everything because we're still within the 80 character limit. So you can give a very good label to your data that way. Instead of what you find here, now look at what you find here. That's how it is. By default, it came like this, and now we have this. So let's also look now what happens because we selected the option, we added an option of no label. So it gives us a flare. So you can see that data set that had so many categorical variables is now basically stripped off. Okay, so we have a status about marriage here, marriage, never married. Now you see they are all dummy variables having values of 0 and 1. Now to make it straightforward, I will just stop at line 8 so you can see what it was before for married and never married. So they're dummy variables. So we had single, married, single, married. So if you were married, you are 1. If you are single, you are 0. And then never married is 0 or 1. It's also binary. Never married. So someone has never been married. So it's only two responses, either a 0 or a 1. So we find things like that, and then so we're going to just take that binary variable and label it, you know. So never married, you can say yes, and never married 0 means no. So, or maybe for clarity, I would say if you are 1, you are never married. If you are 0, you were married. Never married, yeah. So basically I've told you that when you have 1, it turns out to be true for that data you are trying to capture. So let's define label for that. So before we save the file, we need to define that label and attach it. So lab def, now I am using short forms. So saying label define, I'm saying label define, which is in the short abbreviation. I'd mentioned that in module 2. I would say ever underscore married or never married. I just don't want to use the same, you know. So that's fine. So I'll say 1 means yes, and then I just put comma modify. I copy the entire line again, and 0 means, or let's say 1 means never married, 0 means married. Okay, so I only define the label, it does not change anything. So I will do that again, just show that it does not change anything. Let's go back and keep this on one side so we can look at it. So never married, nothing has happened to you because I just defined the label, I did not attach it. So it's very important that you know that when you define a label, you must attach it. So this is the variable of interest. So the next thing to do is say label. So just to be able to differentiate it, you know, let me put it n married. That's the definition. I will now say label values never married is the variable. You can also copy from the variables and just paste here, and you now say n underscore married. So what you've done is that you have, so let's just run it together, run all from the scratch again. When you run now, do you see never married here is, if you had a 0 is married, if you did not have a 0, never married. So that's how it works. That is how this works. And then you can save and then run again. But now when I do no label, it also strips this one off. of any label. So what you find is something like this, just numbers, just numbers. So in the new data set we can cut out these lines and add it to the new data set that we're just building for ourselves. So now when you finish doing all these additions, so let's see. Now for this new data set that I saved and I said load without label, it's only this variable that will be blue. Every other one is black or red. You see? Because that's the only one I work with. So what I want you to do is follow these lines and try to label them one after the other. But you need to know, for example, what 2 stands for, what 1 stands for. That's why before you start labeling, you have to have your definitions very close by. Oftentimes you're asked to look at the questionnaire if it's possible, and then that helps. So basically that's how it works. We have done a few things before, so let's see, let's work on age. So I would remove the no label, because the whole idea is I want to see the labels, the other blues. That's fine, but you can try it. I love people who experiment. That greatly helps. Okay, so this is what we have, and then when we run it down here, down to this portion, let's run it here. This variable of interest here, which was never married, was never labeled from the original data set. So but now we have been able to attach something there. So let's quickly run through our toString and theString again. So when I say age, this is the age variable here. So I say toString string, sorry, spellings have to be correct. toString age, comma, replace. What it does is it just turns age variable to red, which you can find here. That's what it does. But if I say gen new age, it adds the variable to the data set. So, and if you see, so you can see that. So we have the age before and the new age. The only difference is that one is red and one is black. Of course, the black, because it's black, can only do numeric calculations, and the red can only do string calculations. So when you're trying to save a file or do some other manipulation, red may be good. But you are trying to do addition, subtraction, maybe how old will this person be in the next 15 years kind of calculation, then black will be ideal. So remember, with toString and theString, you can generate a new variable. It's optional, and you can replace. So if I theString this new age, which I just created, comma, replace, like I mentioned, all it does, it turns both of them to black. So this was black, we turned it to red, and from red we replaced it with line 19, and it's now black again. So that is how it basically works. So we move on again to something that we had done before too, which is decode the races. So when you say decode race, you have to generate a new variable. So I'll call that new race. So every time you see new underscore something, it means it's just a variable we just created in this session. So when I say decode race, gen new race, so there's race here, which is in blue. But if we get to the end of the data set now, we now have end of data set new race, which is red. So like I told you, decode and encode is shifting between blue and red. And then let's try and encode this new race we have here. So encode new race. So I will say comma gen new underscore new race. So there will be a blue variable created here at the end of the data set. So let's look. Okay, so very important. I think I've been able to bring you up to speed with the race. Now, just a few things to highlight here. First, when you use this encode command, it works in alphabetical order. So the black here is 1 and white here is 3. But if you go check, where are you? Are you? So you'll find that black here is 2, white here is 1. So when you encode, it sorts out the options, string options in alphabetical order. But there is still a way of doing that with the encode command, and that will lead us to more options. But just for the basics right now, we just want to leave it this way. So please, let's leave it at this level. When we go advanced and we look at some of these commands thoroughly, we're going to do a lot of tweaking. So I hope this has been useful so far. And when you're done with all this stuff, you may want to now, work with a date variable, which we don't have here in this data set, but we had already shown you in the rehearsals what you need to do with the date variable. So I will just create, just to emphasize that again, I'll just generate, which we have been telling you you can generate and you can clone. So let's quickly clone first before we go to dates. So if I clone var, like I've mentioned, and let me clone var g new race, or let me say clone underscore new race, I would say equals to new race. So what does it do? It clones this entire thing, and I've told you, like a photocopy, everything word for word, values, everything. The only difference would be the name and of course the order, which they cannot share within the data set. So let's scroll down and see. I've finished running it now. So you see the clone is just making a copy of this. So that's how it works. Now let's go to new race. So clone var, same thing. Yeah, so I'm referring to this variable now and this variable. So you need to talk about the variable that you're going to clone, be on the right hand side of the quality side, and the new one you want to create. Okay, so we run now and that's it. But if you were to gen new race, let's say generate gen new race. Now I'm referring to this column here, equals to new race. You would see that this generate only takes the values, not the labels. So scroll down to the end. So you see these are just the values but not the labels. So clone clones everything, but gen just takes values. So there are many things, the format, the way it looked like, things will change. So yeah, so we find that also yeah, so that's basically do not want to overload you, but it's a practical session, so just bear with me. And then when you're done with all this stuff, you may want to save. So if you save here, and this is not good practice, this was the file you started with. After you have done all these kind of different data processing activities, it's not the best thing to save this again. So I will copy this. I can copy this too. Just copy this line. I just want to alter the name that says NLSU underscore updated. So that's best practice, that you start with something raw, you leave it raw, but by the time you are saving, you have updated because of all these manipulations you have done. So that is like a milestone you have achieved. So every time you achieve a milestone, it's just ideal. For want of a better word, that you save. So basically, that's what happens. We had already mentioned labeling variables. So you see, all these variables are now called race, especially because they were cloned. So you may want to give it a better name. So for example, when you gen new age here, you may want to say label variable. Now I use var because I told you we do abbreviations. New underscore age, which was one of the variables I was just generated, and then call it what age. You can now call it new race, and that's what we have. If we look here carefully when we run the do file, so if you look, can you see new race or new age rather? That's wrong. So this should have been new age. So I want you to, I use that word again, play with this file. This is really the end of the practical session in module 2. We have learned how to define labels, learn how to attach them, learn how to label data sets and variables, learn how to use the encode, decode, and of course we have now learned how to save. So please attempt your own by just looking at any of those files within the system and learn them well. Thank you so much. I will see you in the next module, module 4. Thank you.